Here's number 53 on page 132. Pregnancies last about, mean of 266, standard deviation 16 days. At what percentile is a pregnancy that lasts 240 days? I am going to do a z-score for that. So I did a z-score, and I always like to draw these pictures just to confirm what I'm thinking. Oops, that was a negative, right? A negative 1.625, so it's a very small amount of the area, which is going to be the percentile. So I'm going to do normal CDF. And for that, I get 0.05. So about 5%. 0.05 is for normal CDF. 5% of the pregnancies last less than 240 days. So that means that a pregnancy that lasts 240 days is at the 5th percentile. So now I'm going to look at percentage of pregnancies that last between 240 and 270. So I am going to draw this picture again. And 240, we just did that one, that's way down here. So that's 0.052, or about 5.2%. 5.2% to be a little bit more precise. That's that area. And 270. So let's see, we're at 266, so kind of up in here. 270. I am going to do a z-score again, our old friend. So here's my z-score right here, 0.25. Put that into normal CDF. Negative 100 to 0.25 gives me 0.592 as the area, 59.2. Subtract those two, this one and that will give you this area that's in between them, like that. Okay. Which turns out to be about 54.6%. 54.6% of the pregnancies last between, 240 days, which is down there, and 270 days. Okay, there's that. Let's go to letter C. How long do the longest 20% of the pregnancies last? So, well, the longest 20%. Let me draw a picture of what that looks like. So we have the percentile. So we would be looking at the longest 20%, which is going to be at the 80th percentile. Remember? 80% there, 20% there. Okay, because the percentile tells us all the stuff that's less than that. Okay, I want to figure out what the z-score is for the 80th percentile. Well, this time I'm going to do inverse norm. Well, it turns out that the inverse norm of the 80th percentile is 0.84. 0.84. That's my z-score. So I'm going to take the z-score. I think some of us are pretty good at this. 0.84. We're going to multiply that by the standard deviation, which is 16, and add that to the average length of the pregnancy, 266. Let me do that. And the answer is 279 days, 0.44. Okay, so that's the answer to that one. Okay, for letter A, I'm assuming that you read this problem. We're talking about the adhesion of a diesel locomotive. Here is the average. Meow. See, we're using mu now, and here is the standard deviation for a sample. Okay, so let's see, daily route. Oh, right here, you can barely see it. At least 30. So we're going to do a z-score, because the number we're interested is 0.3 minus the average, which is 0.37, divided by the standard deviation, which is 0.04. Okay, that's how we kind of set these up. And I'm going to let you do the rest of it. Okay, so these are a little bit different, this problem here. We are going to look at the average adhesion rate. or mu. What would we have to change that in order to maintain this less than 2%? Okay, late arrivals. So in other words, here I am going to figure out the z-score for 2%, which means I need to do the inverse norm. I'll write that down, inverse norm of 0.02. All right, let me plug that in the calculator. So I get the inverse norm of 0.02, which happens to be negative 2.05. So that's the z-score. Now we're still going to work with 0.3. That was from, what is it, exercise 55. We're not changing that. Minus, we don't know what the standard deviation is. We are going to maintain, let's see, what was the standard deviation? Oh, 0.04. So, using algebra, we are going to solve for mu. Well, do you remember how to do that? I would start by multiplying both sides by 0.04, right, to get rid of this fraction. And that's what we get when we do that. Now, we would just subtract 0.3 from both sides, like this, to there. Let's see what we get there. And there you have it. That's what you would have to have the average adhesion rate to be in order for that to happen. Now, I think this next one is, how do we solve for the standard deviation? That's for letter B. And I'm going to let you try that one. Same kind of an idea, except this time we have mu, and we are going to have a variable for the standard deviation. Okay, deciles, the lowest 10% and the highest 10%. So I'm going to draw a graph, see what that looks like. That's what I always do. And it looks like this. And basically we have 10% of the area there and the highest 10% of this area here. Okay, what are the deciles of the normal standard normal distribution? So I think what they're saying here is, here we are at 0, right? How far down, how many standard deviations will we have to go to get to that 10% place? So for this one, I would just do inverse norm of 0.10. Inverse norm. Okay, let me see if I get this right. Ha! Yes. So we have to go down, so it's kind of like the z-score. What is our z-score to get to that 10% area? So it's going to be a z-score. The z would have to be negative 1.28. How many standard deviations do we have to go down to get to that 10%? Well, it's a symmetric graph, so that's a negative 1.28. So on the high side, it would have to be a positive 1.28. So that is for letter A. So we can use this fact that we just came up with right here to approach letter B. The heights of young women are approximately normal with a mean of 64.5. So 64.5, that's the average. Standard deviation of 2.5. 2.5. So what would I do to figure out the deciles? The lowest 10% would be, well, 2.5 times negative 1.28. And then, let's do that. So what I do is negative 1.28 times the standard deviation gives me 3.2, subtracted from 64.5. So here we are at the average and down here. And then, of course, what would we do? We would take the same number and add it. 3.2 plus 64.5. Okay, let's see what that looks like. So another way to look at this thing is, I'm going to draw another graph, is like this. We've got this graph, right? Right in the middle, right? Zero standard deviation is 64.5. And we're going to add a certain amount and subtract a certain amount to see where we're at. And there it is. We are adding and subtracting this 3.2 to this. So what does that tell us? Well, it tells us that 10% of these women are shorter than this amount right there, and 10% of the women are taller than that right there. Okay. I want to double check the answer key to make sure that I am right. Okay, I got it. All right, that's enough for tonight, and we can go over some more questions tomorrow.